All right, so in this lesson, we are going to learn how you handle quadratic word problems. And you can obviously see that the format of this video is a little different than usual because there's a lot of text going on in this kind of lesson here. But I will tell you guys what you need to have copied down into your notes. I am going to make you write some of it down so you have good examples to look at. But this top part right here, don't worry about. Just get your title down, and I'll tell you when you should start writing. This first part right here is talking about something called projectile motion. And when you picture projectile motion, it's basically anything where gravity is involved. Picture if you throw something, it goes up and it comes back down. So it seems very logical that anything involving gravity would have sort of a parabolic pattern to it. The force of gravity itself is in squared. It's like a squared quantity. So quadratics and gravity just go together really, really well. And this little first paragraph here talks about how you actually build the equation for a projectile motion problem. So when you look at one of these, the height is this part where the y would normally go over here. There's going to be a number, either a negative 16, or sometimes you'll see a negative 4.9. These are the two numbers you will see for your A. Negative 16 has to do with the force of gravity when you're in feet. Your problem's in feet. And if your problem's in meters, this is the number you'll see instead. So one of these two numbers is always going to be in the front of this kind of problem, assuming we're dealing with like Earth gravity here. Then you're going to have your squared term. The linear term here in the middle, the V with a little O on it right there, is your starting velocity. So how hard do you throw something? And then you have your time again. And then this last part right here, this S with the O on it, is your initial height. So how high off the ground is the object when the problem begins? This all right here looks very complicated, but it's actually very easy to write a quadratic word problem. So this part, again, you can just look at. Still don't have to write anything down yet. When I scroll down, I'll have you copy that. But we have an object that is launched directly upward at 64 feet per second. That's a velocity right here. That's the force we're putting on it. And then the platform is 80 feet high. That's our starting height. And the problem is in feet. Because it's in feet, I know it's going to be a negative 16 t squared. The initial velocity is the 64 feet per second. So I'm going to have a 64t, and it starts out 80 feet high. So it's going to look like that. So it's actually not that hard to build a equation for these basic kind of projectile motion word problems. So let me scroll down here, and then this part I do want you guys to copy. This problem right here. There's 4 parts to it here, and they give us an equation for our rockets. And you can see that the initial velocity is 128. The problem is in feet, and it starts out on the ground. That's why there's no number over here for C in the equation. But this is the basic equation that we're going to be working with for this problem. When we get going with this, I am actually going to change this number to make it like an uglier answer. So make that say 119. But I do want you guys to copy everything you see on the screen here into your notebook so you have a good example to look at later. So my first problem says, how long will it take for the rocket to return to the ground? The height is given by y, and the time is given by t. So in a problem like this, they could give you a time. It could say something like, oh, how high will the rocket be in 2 seconds? If it was something like that, that kind is really easy. You just plug a 2 in right here, and you can get your answer. But this one is asking us for the rocket to return to the ground. Think about what you know about the rocket when it's on the ground. You actually know the height, and the height is going to be a 0. So that is something that's really important to remember. When something is on the ground, its height is 0. So I would plug in a 0 for the height on this equation, and I'm going to have this setup. Now, we have learned so many different methods for solving quadratics right here. You guys have like 5 choices for what to do. You just pick your favorite, and you solve the problem that way. I am actually going to show you guys a new-ish option, a variation of factoring. Because this problem doesn't have a plain number over here, I'm actually going to pull out a GCF I'm just going to straight up pull out negative 16, even if it doesn't go into this. I'll find out in a second if it does, just because I want to get the nice, easy parenthesis right here. If I pull out a negative 16t, this is going to say t, and then 128 divided by negative 16 actually is a negative 8. So I have this sort of setup here when I pulled out my GCF. Remember that when you factor, you have to solve each of your pieces. So this part right here, if I equal it to 0, I'm going to get t equals 8. And then this part, if I equal that guy to 0, I just divide by negative 16. So I'm going to get t equals 0. Now, why would it make sense for there to be two answers to this problem? Well, the rocket starts out on the ground. So here's my rocket. It goes in the air, and it comes back down. So it starts at 0 seconds on the ground. It ends at 8 seconds on the ground. The problem said, when will it return to the ground? So it will take 8 seconds for that to occur. When you get your answers, there'll generally be two of them. You have to ask yourself, does one make sense? Does the other? And figure out what's going on. So that's the first problem. I'm going to go ahead and erase this here so we can look at the next. And don't forget, for this next one, I changed this to a 119 here just to have a messier number to work with. So it's the same sort of setup right here, except this time we're going to put a 119 for the height. So my equation is going to say 119 equals, and then I have the rest of this setup. The last problem, I was able to use a nice little factoring trick, and it was actually pretty easy to solve. This one, not so much. So in a word problem, when your numbers are uglier, believe it or not, this actually isn't going to be bad at all. What I'm going to do is take my equation right here, and I'm going to throw it into the quadratic formula. So when I do that, it's going to say x equals negative b, that'd be negative 128, plus or minus. And then on the inside here, I'm going to go ahead and I'm going to do 128 squared, which is 16384. Then I'm going to do negative 4 times negative 16 times negative 119, which is a negative 7616. So I'm just kind of using my calculator to help me out here. All over 2 times a, that's going to be over a negative 32. Now, if this was a problem from last video, where we were doing factor trees and stuff, this would be awful. This is such a big number to do a tree and reduce it. It's just one big mess. But here is the good news. With word problems in general, giving an answer with a square root, oh, it's going to take 2 plus or minus 3 root 7 seconds, that doesn't make much sense. We want a decimal, actually, for this sort of problem. So write yourself a note that decimals are okay in word problems. That actually is great news for us, because what I'm going to end up doing here, instead of having to do a factor tree and all that, I'm just going to type this thing into my calculator. And I want to show you guys how that looks, because it's way easier than you would think. All I'm going to do is type in the whole numerator. With a plus or minus just means I do it separately, so I'm going to do the plus answer first. And I'm going to type in the top just like it looks. After I type in the top, I have to remember to hit enter before I divide. If you don't, it will mess it up. So I hit enter, and then I divide by negative 32. So my first answer is 1.07. And I'm going to write that down real fast. So I got t equals, no more work needed, just t equals 1.07. And then I'm going to go back and get my second answer the same way. Now, the nice thing about these calculators is you can just scroll up to this step right here and highlight it, hit enter, and it'll pull it back down for you, and you can just go change it to say minus instead. Less work. I hit enter. I divide by negative 32. So my other answer is 6.93, I guess, if I wanted to round that. So 6.93. When you do a quadratic word problem, sometimes one answer makes sense, sometimes they both make sense, sometimes neither makes sense. You just have to think about the problem. Both of these answers actually make sense. Okay? Think about the rocket here. Here's my grounds. The rocket takes off at 0 seconds. It's going to go up into the air and come back down. But it's going to get to 119 on the way up at like 1.07 seconds. It's going to keep on going up through the air, and it's going to get back to 119 again at 6.93 seconds. So sometimes both answers do make sense. This one, they didn't really specify. They just said, hey, when's it 119? Well, it's going to happen at 1.07 seconds, and it's going to happen again at 6.93 seconds. Both of those answers will actually make sense in the problem. So my next question here says, how long will it take the rocket to reach its maximum heights? And then what is the actual maximum heights? This right here, we have actually talked about already. When you see that word maximum, that should send off signals to you guys that we are finding the vertex. Vertex is the maximum of an upside down parabola. So what I need to do with this equation here is just do negative b over 2a. So if I set that up for this problem, negative b over 2a, that's going to be negative 128 over 2 times negative 16, which is negative 32. And if I divide those in the calculator, it's going to be 4. That's my x, which is like t in this problem. And then I plug that x back in to get y. So let me do that real fast here and see what I end up getting when I plug in my 4. It looks like you get a 256. So that's my vertex, and I just have to figure out what these numbers mean. This one says, how long will it take to reach the maximum? Well, that's my time. So it's going to take 4 seconds to get to the maximum heights. And then what is the actual maximum height? It's going to be 256 feet. So quadratic word problems with projectile motion boil down into really 3 different kinds of problems. The easiest, which I didn't even bother doing here with you guys, is if they ask about, oh, how high will it be in 3 seconds? Then you just plug in 3 for the x's and you're good to go. The second style is when they give you the y. And if they do that, you have to do quad formula or factoring or something like that. And the last style of problem, we'll talk about that maximum or minimum, which is doing vertex stuff instead. So those are kind of your 3 options for what's going on there. We're going to do one more for this video here. I'm not going to go into the second page. We might do the second page in class at some points, but I do want to do this problem right here about the ladder. So write down the ladder problem, and this will be the last one I do with you guys in this video. So when you look at a geometry style problem, drawing a picture is always a good option here. And the wall in this problem, there's my sweet wall, it is 15 feet high. They've got a ladder that's leaning against the wall. So there's my ladder. And it doesn't tell me how long the ladder is, but it does say the distance from the wall to the bottom of the ladder, so this part right here, is 1 foot more. Wait, let's see. The length of the ladder is 1 foot more than twice its distance from the wall. So I don't know how far it is to the wall. That's going to be x. But this is 1 foot more than twice that, so it's 2x plus 1. So basically, if I was going to draw this as a picture without any ladder in it, it would be a triangle that looks like this. So they're asking me right now to solve that for x, and then to figure out the ladder and stuff like that. So to get the answer for this problem, think about what you would actually do right here. This is going to be a Pythagorean theorem style problem, where I would do x squared plus 15 squared equals, and that whole 2x plus 1 does need to be squared. What that means is that this guy, don't break your promise, you do have to do FOIL on that parenthesis. So you're going to get x squared plus 225, and then if you FOIL this guy out, it'll say 4x squared plus 4x plus 1. So projectile motion is very commonly quadratic. Things like geometry problems can end up quadratic somewhat frequently. Pythag is a good example of that. Also area problems, you could have to do FOIL. They pop up in lots of different contexts. Now I'm just doing regular solve for x math. So I'm going to go ahead and I'm going to subtract over my x squared and my 225 as well. Now my equation is going to say 3x squared plus 4x minus 224 equals 0. At this point, I'm just going to throw this thing in the quad formula and not worry about trying to figure out if it factors or anything like that. So let's see what I end up getting there when I do my negative 4 times 3 times negative 224. That's a positive 2688 all over 2 times a. And then I'm just going to do the same thing. I'll show it again so you guys can get a second glimpse at that. You can just type this into the calculator and not worry about factor trees for this style of problem. So if I do that, I would hit enter, and then I would divide by 6. So one of my answers is 8, and then the second answer, if I go back and get that, change it to a minus here. My second answer is going to be negative 9.3. So I get x equals 8, and I get x equals negative 9.3 repeating. So when you do quadratic word problems, sometimes one answer makes sense, sometimes they both do, sometimes neither answer makes sense. Obviously in this problem, we're looking at distances, and it does not make sense to have a negative distance from the wall right here. So that answer we're just going to reject. It doesn't help us with our problem. The other answer though is good. This part right here must be 8. So that means my ladder is actually going to be 17 feet long. And if we look at what they actually wanted in the problem, they asked for find the distance from the wall to the bottom of the ladder. So they wanted the 8 part of that answer, but you just look and see what's going on. There are a few other word problems in these notes, but we'll just do it to get some practice in class and not worry about them in here. So if you got those two about the ladder and the projectile motion, then you are good to go with your word problem notes.